technology that's on the horizon. Emissions reduction. Carnot Limited. Ultra-efficient ceramic engines. Emissions from offshore oil and gas activities account for 3% of UK greenhouse gas emissions, and 74% of CO2 emissions offshore come from power-generating equipment, such as turbines and generators. To achieve our net zero goals, we need more efficient power solutions that will reduce emissions for both operational and decommissioning activities. Carnot is developing an ultra-efficient, low-cost engine from high-grade ceramics. Using two types of ceramics for its structure and insulation, it requires no cooling, which allows the engine to be twice as efficient and use half the fuel, and drives down maintenance costs. As a replacement for existing equipment or installed as part of the facility of the future, the engine could provide low-emissions power offshore. Half the weight of current generators, and with modular 300 kilowatt units, power supply could potentially be ramped up or down to meet requirements. The engine also has multi-fuel capability, diesel, biofuels, or hydrogen, making it a future-proofed, low-cost stepping stone to net zero. This solution could revolutionize off-grid energy supply and dramatically reduce the carbon footprint of all offshore operations. The Carnot engine could deliver a 50% increase in fuel efficiency. This will directly translate into a 50% decrease in both fuel costs and CO2 emissions when compared to traditional power generation. Energy system integration. Axis. Floating wind turbine foundations. Europe will need between 230 and 450 gigawatts of offshore wind by 2050, 4 times the planned UK capacity. 85% of this is likely to be developed offshore in the northern European waters, as much of this resource cannot be accessed by fixed offshore wind. A huge opportunity exists for the UK to lead in floating offshore wind. We need technology solutions to tackle the innovation gaps and reduce the cost of fabrication and installation. Axis has developed a new floating foundation solution based on proven oil and gas technology. Originally designed to provide subsea midwater arches in the Buchan Alpha field, the tension leg buoy concept has now been optimized to provide a foundation for floating offshore wind turbines. The concept minimizes both the weight of the steel structure and the fabrication costs, while maximizing turbine stability and the total energy capacity. The technology could provide stability for the largest floating offshore turbines. The Axis system lends itself to a safe, easy, and low-cost installation. It could potentially reduce foundation costs by 25 to 30%, and the cost of energy from floating wind by 10 to 15%, and generate global revenues of £18 billion to the UK supply chain over the next 10 years. Offshore Energy 4.0. Autonomous robotics. Smart, cost-effective OBS. A fully autonomous offshore energy field that is explored, operated and maintained remotely is critical for a net zero future. High-quality seismic data is essential to reduce subsurface uncertainty in oil and gas exploration and can help optimize development, maximize recovery and reduce emissions. Traditional methods for obtaining ocean bottom seismic (OBS) imaging are double the cost of a conventional towed streamer, which limits the widespread use of OBS imaging to optimizing production from existing resources and near-field opportunities. Developed by Autonomous Robotics, Flying Nodes is a fully autonomous, self-propelled ocean bottom node that has the potential to reduce the cost of acquiring ocean bottom seismic to a rate comparable to towed streamer acquisition. 3,500 nodes are deployed from a vessel as a swarm and descend to encoded positions on the seabed. Acoustic navigation is used for final positioning, enabling deployment in and around subsea infrastructure. With autonomous delivery and retrieval from the seabed in water depths of up to 3,000 meters, they can record data for up to 60 days, making it an accessible, affordable, and viable option for use in exploration, 4D studies, and monitoring for CCUS, or for the seismic monitoring of wind turbine foundations. Affordable seismic mapping will help unlock the full potential of the UKCS. Autonomous robotics calculates a shallow water survey cost of £30,000 per square kilometre with flying nodes, compared to £60,000 per square kilometre for a conventional towed streamer. This 50% saving would translate into a £7.5 million saving on the survey of one UKCS block alone. Capable of being deployed and recovered up to 10 times faster than ROV deployed nodes, autonomous robotics flying nodes will greatly reduce the cost of acquiring seabed seismic data through the asset lifecycle and beyond.